Okay, so this is going to be the practice exam for Calc 2. So I'm working ones that I know are similar to the ones on the exam. And obviously I have to make you do a lot of antiderivatives, right? I mean, the whole course is two-thirds of the course is integration techniques. So, you're definitely going to see something like this. This is a 1B. I have to give you powers that are fractions, and powers that are negatives and all you have to deal with all sorts of stuff. I have to make sure you can do all of them. And the first thing that I have to make sure you can do is how to rewrite them properly. Now, when you see this, right, this is the square root, but it's to the seventh power. So the root is 2. So it's going to be x, and that's x to the seventh, right? I mean, that's x to the seventh. And then the square root part comes from the 2 on the bottom. So I have to rewrite it now. The problem is, see, students will do this right away, and then they're going to get it wrong. This is on the bottom of the fraction. So you have to remember to make that power negative. So it's negative 7 over 2. So, students will do it right. They'll put 7 over 2 in, but just they'll make the mistake of not moving it from the bottom to the top. Remember, if you have something on the bottom, this is why that one's there too. So, you have to take this one up to the top and write it like this so that you can use the power rule, right? This is how you do a negative exponent. If I asked you to do 3 to the negative 2 power, you would have to flip that power over and make it positive in order to compute it, right? You have to take the reciprocal. Now, this one is about as easy as it gets. I put square root again, so that's just 1/2. Now, I wouldn't do this on the exam, and I'll tell you why. You have a second root here. I would probably make that 3. So it would be cube root, and then you would do 1/3. I really actually should probably do that, but I don't want to change. I don't want to do it differently than it is on the sheet. But I wouldn't, if I already have a square root once, I'm not going to do it again on the exam. I try to make them all different. You have a third root, a fourth root, whatever it is. So, but this is what I put on the thing. Don't forget my dx. So now I can do my antiderivative. And again, this is where people do weird things. So I'm going to add 1 to the power. Now, I want to do this on the side because I want to put what my new power is going to be, right? 1 is 2 over 2. So I'm going to just do that. I'm going to get negative 5 over 2. Obviously, you have to show me something. You can't just go from here to here. I need to at least see this on the side, or you could do it. You could have done it here. That's okay. I just want to save board space when I'm doing them. Okay. So now, again, some people will just take that power and go put it down here, which, not only looks ridiculous, but students do it wrong. Notice 10 is divisible by 5 and 2. That's the reason I chose these numbers. So what I taught you was very, very simple to do. Just take this, flip it over, and put it in the front. It's exactly the same thing you would do if you were to divide it out. All right, now over here, I have negative 6. I'm going to add 1 to that power, which makes it negative 3. Now I'm going to, you're dividing. When they're whole numbers, it's easy. I can just put it underneath there, or I can just write negative 1/3. It's the same thing. When they're whole numbers, this adding and dividing works just great. It works less great when they're fractions because it's more complicated. So if it's just whole numbers, I'll just put it underneath the one that was there. That's a whole number, that's a whole number. So that one's easy. But again, here I won't do that. I have 12. Now when I add 1 to 1/2, I get 3/2. And again, if you want to make it easy for yourself, probably should have put the 12 closer. Flip that over, which is 2/3. Put it in front of 12. So I added 1 to the power, flipped it over, put it in front. Added 1 to the power, divided by it. Same thing, flip it over, put it in front. Add 1 to the power, flipped it over, put it in front. And now I have to simplify. So I want to see this step, right? One at a time. I have to see that step. All I have to do is neaten this up. Divide 5 into 10, or 10 by 5. Right? 5 divided by 5 is 1. 10 divided by 5 is 2. That gives me negative 4 in front of there. Please, please, whatever you do, leave it alone. Don't try to write this back as a root. Don't move it to the bottom. When I make my answer key, I don't do that. I leave it just like this. And I want you to leave it like that. Negative 6 divided by negative 3 is positive 2. Just watch your signs here. Same thing. You have a negative power. Leave it alone. don't do this, right? You don't need to do this. I'm not forcing you to do this. Yes, I know there are professors that say you can't have negatives in your answer. Why? Why not? I allow it, so leave it like that. Same thing. You don't have to write them back as roots. It's absolutely ludicrous. So 12 divided by 3 is 4. 4 times 2 is 8. They have 8 to the 3 halves. And yes, I forgot my plus C. I mean, I didn't forget. I just was focused on everything else. So 1, 2, 3 points. Obviously, if you forgot the plus C and I have to write it for you, I'll look the other way once. But if there's no plus C anywhere on the test where it's supposed to be, then I will take 1 point off. So, but this is how it's graded: 1 point, 1 point, 1 point. Very simple, right? So you'll have a few of those scattered throughout the test. Not a whole lot because you're going to be in. You can do an integration basically on everything. So I don't need to ask too much, but I do have to make sure you can do the basic ones before we get to the harder ones. All right, so I'm gonna do them in the order they are on the sheet. Okay, so this is number 3. I decided to skip over 2 because first of all, they're definite integrals. When you're finding areas and volumes, you're doing definite integrals. So it's completely pointless for me to go and sit and do those other ones. I might not even have that separately on the test. I mean, there might be one there, but you're gonna do it here. Now, this is the one where you're doing the area between the two curves. You have no choice but to make yourself a rough sketch. They're both parabolas. I know that because they have x squareds. I know this parabola is going to be upside down, sad face, because it's got a negative. This one's going to be smiley face because it's got a positive. The 6 is telling you 1, 2, 3, 4, 5, 6. I don't have to be super duper precise, but the 6 is telling me where that graph crosses the y-axis. And then I know that it's going to go downwards. And I know that because there's a negative. Now, this other one is down at -2, and then it's going to go up. Now they're going to meet somewhere, which I'm about to figure out. And that's important. I can't integrate. I can't set up my integral unless I know. So I'm looking for all this space right there. That's a lot. That's a big area. Some of it is below the x-axis, but most of it is above, so I know that my answer will be positive. This is important. If you make yourself a rough sketch and you see the vast majority of the graph is below the x-axis, then you should be expecting a negative answer when you're looking for an area, because that just meant that the area is concentrated below. So I have to set these equal to each other. So it's obvious that this dude is on the top. He's the one up there. So he's above. So I know he's gonna go first. So I'm gonna set them equal to each other. Why do I need to do this? I need to figure out where they meet so that I know where to set up my integral. So I want to keep x squared positive. So I'm gonna make sure that the x squareds go together. 1x squared and 1x squared make 2x squareds. And no offense, but if you F this up, I don't know what to tell you. So equal, add 2 and add 2. I mean, you can't make mistakes like that in the calculus 2 level. It's a little ridiculous. So divide by 2. So I'm going to get x squared equals 4. Look, you can set it equal to 0 and factor it, or you can take the square root, but you have to remember, you have to be careful. You're taking the positive and negative roots of 4. So that means that x has to be positive or -2. So this is where the graphs meet. This is what I'm looking for when I'm trying to find the area. That's where. So my integral, I'm going to set up the integral from -2 to 2. The one that's on top, which is the upside down parabola. And then I'm going to subtract, parentheses, that entire thing, the one that's underneath. So that's the integral. And again, you can mess this up. You can mess this up. You do the signs wrong. I mean, there's a lot of places that if you are careless and not paying attention, you'll make a mistake. So graph on top, you can distribute that minus, you get -x squared, and then a negative and a negative is +2. There's a very high potential for a mistake there. So you're going to end up doing integral from -2 to 2. You have -2x squareds, and then you have a +6 and a +2, that's +8. My dx got messed up. There we go. So again, add 1 to the power, right? Now you just take the antiderivative. When you add 1 to the power, and then you divide, right? Flip and multiply, same thing. When they're whole numbers, it's kind of trivial. You just put whatever the new power is underneath that number that was there. And then when you integrate 8, you just get 8x. And then I want to compute that from -2 to 2. Now, since I need room, I have to delete all of this because it takes some work to do this. So plug the number on top. And look, I'm doing it because you have to do it. And, I know people mess up this part, and it's very easy to mess up. So first you plug in 2, everywhere you see X. Then I'm going to plug -2 everywhere I see X. And again, I do it very slow and I do it very careful. Now, of the whole question, the answer is only like if this question is worth like 6, the answer is worth 1 point. Because it's not that I don't care if you mess up here. I mean, it matters. It's important that you're able to do things with fractions and numbers and signs, but that's not the part of this course. The main part of this course is, can you do antiderivatives? Can you do the techniques? So, if you mess this up, it's not the end of the world. 2 to the third is 8. You're going to times it by -2. And then 8 times 2 is 16. Now again, here's where I do these very intelligently, right? Don't forget your minus. Now, -2 to the third is -8. And I'm doing -8 times -2, which is +16 thirds. You have to be very careful. That's -16. Now, here's where I do this differently, and I do this in a very intelligent way. I have a +16, a minus, and a -16 is another +16. That gives me 32, right? I like to do the whole numbers first. Then I have a -16 over 3, take away 16 over 3. See, very smart, very smart. I don't want to start going crazy, make these the same, make these. You can do that. I like to do it easy and very simple. So over there I have -32 over 3, right? So I used up my fractions. So combine the whole numbers, combine the fractions, and then I have to make this one have 3, right? You have to make the least common denominator. That's 96 over 3, right? 3 times 2, 3 times 3. That's kind of ridiculous, but that works there. So you have 96 over 3 minus 32 over 3, so that's 64 over 3. So that is the area of that space. And it's pretty big, and it looks pretty big. Like, if you had done this problem and you got 1/3, and you look at that huge ass area that you created, and you see an answer of 1/3, you should be a little suspicious that, what, I don't think it's that small, right? I mean, it has to kind of be. It looks like a big space, all that there, right? You're taking away the negative part that actually detracts from the area, but this part there is really big. So, you have no way of knowing for sure, but you can kind of say to yourself that number looks a little too big or a little too small. Certainly if it was too small. All right, so that you only have one of these on the test, thank God. It's hard for you to do, and it's hard to grade. So I won't ask more than that. All right, I'm gonna do the volume. I'm gonna do again the one that I know I have on the test. Okay, so this is the volume one that I was just saying. And again, is it super hard? No, it's not super hard. I know that I'm gonna have one like this. I know that you square it, like you have a 6 there, and it's a little silly. But really, the volume is nothing but the formula. As long as you know the formula. And again, I'm gonna just put the pi in front when I do these. Remember when I showed you that the shape was spinning around, you get lots of little circles. So, and it's solid. I always draw the donut, it's bad. So it's a solid shape spinning around. So you have a series of circles that are just all there. So you're taking areas of circles. That's why the pi is there, because it's right, pi r squared. So you have to take whatever that function is. Definitely didn't write my parentheses big enough. Now I'm going to write x to the 1/6 first. You have to square that, right? It's pi r squared. The r is always the function, whatever it is. And it's supposed to say f of x. I just made a y. I don't even know why I did that. It really should be f of x. We don't do y equals anymore. Although we've been doing it when the area between the curves, because you got to graph them. So you got to square it first. That's why I picked 1/6. You might get 1/4, which leaves you with a square root, which is 1/2. Here I'm going to be left with, now this is, you got to be very careful because people screw it up. Remember what I said, when you have something on the bottom, you want to move it upstairs by switching the sign. That's the first step of the whole thing. Now I'm going to square that next. I'm going to write all these steps, but people mess this up, and it's really easy to mess up. I mean, you have to know these exponent rules. So I didn't leave enough space for my pi. I'm going to squeeze it over there. So I'm going to have x to the minus 1/6 squared dx. So the rule when you do a power to a power is to times the powers together. And since people do screw up fractions, you do it very carefully. I'm going to do negative 1/6 times 2, right? That's how you compute that. So it just becomes negative 1/3. So I have pi integral, whoops, I forgot my numbers, 1 to 8. Can't forget that. I have to tell you where you're spinning it around from. So would have put that in the end anyway. I was so concentrating on the power. So you have x to the minus 1/3 dx. So let's take a second to stop, make sure we did everything right. I have to square this. I move the power up by making it negative. I times the power by 2, which gives me here. I have my pi, and now I have to put my numbers that I'm going to integrate between. So, whatever the heck, 1/6 looks something like this. And if you're going to spin it around between 1 and 8, you end up with something that looks like that, but actually not that part, the other part. So that's what you're doing. You're trying to find the volume of that shape. So now I have to find the antiderivative. So same thing. I kind of painted myself in a corner here. All right, so I'm going to keep my pi. Now I'm going to add 1 to the power. I always do this on the side. This is just a personal preference. I add 1 to that power. I get 2/3. And now I'm going to flip that power over and put it in the front. Again, I don't like seeing this. It just looks stupid. And what do you do with this anyway? Like, fine, even if you compute it, then you have 2/3 here, and then on the bottom you have 2/3 there. And it's like, what is the purpose? Because you're still just taking 1, right? Keep, change, flip. You're still gonna flip this over and go put it there. Why not just do it right there in one easy, simple step? This is really, really inefficient. I don't care for this. I've never shown integration that way. I understand some teachers do it that way, but I think it's really foolish and inefficient. So hopefully you'll even attempt to do what I do, which is always a smart thing to do. All right, so I found my antiderivative, added 1 to the power, flipped it over, put it in front. I kept my pi. Very easy to lose it. People forget it all the time. And now I'm going to evaluate it from 1 to 8. This is the point where you don't want to leave it like that in this case, right? I have x squared, but I have a root. I have a cube root, right? The 3 on the bottom represents cube root. And now I can do this, but I certainly don't want to, because you might get some really big numbers there. What I am going to do, and the smart thing to do, is to do the cube root first and then square it. So let me write it that way. Keep the pi, 3/2. So I'm going to put cube root of x. Jesus, pretty got all messed up. Squared, evaluated, 8 and 1. Now again, I just, for convenience, I'll fit it over here. So I'm going to put the pi. I'm going to do the whole thing and get the numbers, and then I'll do the pi. Actually, you know what? I'm going to go you one better than that. I'm going to take the 3/2, since it's going to be in both, and I'm going to combine it with the pi and put it out there, so that all I have to do is do this root thing with 8 and 1, and then later at the end I'll just times it by 3 pi over 2, or 3/2 pi, whatever you like. So I'm going to plug in 8 first. I'm going to do the cube root of 8, and I'm going to square it. And then I'm going to subtract the cube root of 1 and square it. Right? This is a constant. I can take that whole thing and just move it in the front, and then just compute only this. It's just easier. It's just easier. Then you don't have to worry about the fractions here. So cube root of 8 is 2, and then I have to square it. Cube root of 1, look, 1 to any power is 1. Cube root of 1 is 1, and then 1 squared is 1. So I end up with that. 2 squared is 4, minus 1. So that's 3. So the number inside the parentheses turned out to be a 3. I still have that 3 pi over 2 hanging out in the front waiting to see what number would land here, and now I know it's a 3. So I just times this by 3. And remember, don't be dumbass and tell me 9/6. This is ridiculous, okay? In a Calc 2 class that you don't understand how to times this together, right? You get 9 pi on top, you get 2 on the bottom. So that's the volume of that shape revolved around the x-axis. I don't do y, and I don't do this other weird stuff. It's a lot more complicated. And this is complicated enough, just revolving around x. I don't need to make you spin the thing around the y-axis or something else, all right? Pi r squared, rewrite, square it, antiderivative, put it in the correct form for me to compute, which is a root. You know, a lot of people will get here and then they'll come up to me and say, I don't know how to do this. You shouldn't know. I mean, you shouldn't know how to do it, but you know, I would vastly prefer you show me this. I don't want you to just compute this in your mind. I want you to show me that you understand it's a cube root and then you're squaring it and you write it all out nice and neat, all the work, all the steps. If I take the time to write it all out, and you have to write it all out. I mean, this is how it goes. All right, so I think I'm gonna do, oh, definitely gonna set up the next one. Okay. So I'm gonna do the volume between. It's disaster. All right, the volume between the curves. This is where I understand how difficult this can be, and so I will only have you set it up. It's still involved. It's still a lot of steps, and it's still. I mean, it's worth like 4 or 5 points because there's a whole bunch of stuff you have to do. Now, there's one big problem. When you set up the volume, it's going to be the same type of thing. It's going to be pi, but you know, from whatever to whatever. So you have to find that too. It's always going to be the one on the top squared minus the one on the bottom squared. Now, you know, they do call it outer and inner, but we can still say top and bottom. The problem with these two graphs is that they're both here at 0. So what I'm going to do this time, I am going to draw the parabola first because it's easy to draw, right? It's centered at 0, 0, and goes like that. I'm going to set them equal first, and I'm going to solve it. And the reason that I'm going to do that is because I have to determine which one is on the top, because this one is at 0, 0, and this one is at 0, 0. So how the heck do I know which one is above? I'm not sure, so I'm gonna do this now. I do know, but so set them equal. Bring it over to 0, factor out to GCF. So that means that you get x equals 0, x equal 2. A lot of people like to skip this work. You know, look, if I'm grading an exam and I see that this work is not there, if I see that you just somehow got 0 and 2 magically, I did it in my mind. Good for you, but you know, you have to justify, right? This is all about justifying your work to me, justifying where these numbers came from. So that's where they came from. Now, actually, I am going to redraw this, and I'm actually going to be a little bit more precise here. I'm going to put 1 and 2. Now, I'm actually going to compute it because I know they're going to meet at 0, obviously, since they both start at 0. And I know that they're going to meet at 2. I'm actually going to plug 1 into both of them and see where it lands. So 1, 2, 3. When I plug 1 into the parabola, 1 squared is 1. I get 1. When I plug 2 into the parabola, I'm up at 4. Now, again, I'm not going to draw this super awesome, but it's good enough. Now, when I plug 1 into the line, I get 2. So this line, this is the problem. It's not, I drew this badly. This is too far. So this is supposed to be a straight line. There's no way I can fix this, but it's a straight line. What I want you to see though is that the line only between, look, this parabola gets way bigger, but between 0 and 2, the line is above the parabola. So you have to kind of sort of see what it does at the number 1. And the line is at y equals 2, the parabola is at y equal 1. That means that the line is above. So my volume is going to be pi from 0 to 2. That's why I found that. The top is the line. The bottom is the parabola. Now, this is a little too simple. Don't forget my dx. It should be there. I'm not mean enough to take 1 point off if you forget to write dx. I will write it, and I'll put a little star there to let you know that you should have lost a point, but I won't take that point off. Now, I'm going to show you after that. The one of the tests is a little bit more complicated than this, and I'm going to talk about how I changed it. So I have pi from 0 to 2. Now, you're going to square that, so be very careful. It's 2 times 2, and it's x times x. And then over here, when you square x squared, you get x to the 4th. You are done. You are done, done, done. If you think about it, if you were to integrate this right over there, you get 1/5 x to the 5th. Yes. Even plugging in 0 and 2. Look, you guys did it in the homework, so you understand how complicated it is to compute these. These numbers get crazy big, crazy nasty. You have the pi there. It's just it's ludicrous. I don't need to make you compute this. You have other places on the test where you're computing integrals. This one is really complicated, so you're going to stop here. The problem is over. Now notice, I did simplify from here to here. from here to here. This is why the one on the test, I'm going to show you the big secret. So the one of these on the test would be like this, but then the other one is going to be something like this. So when you get here, you would have that, and that's a little, and you understand that that's more complicated to multiply that out, right? You would get 4x squared plus 4x plus 1 minus x to the fourth, right? So this is the change. This is how it will be on the test. I make it slightly more complicated to times it out because first of all, I want to make sure you can do this. I mean, even it sounds stupid and ridiculous. I'm seeing things in a Calc 2 class that people can't do basic algebra. I mean, it's ludicrous. Got to make sure you can set it up right. So this is what it will look like versus the one that was on the sheet. Now it's very similar, but I beefed it up ever so slightly. All right, so set them equal. The graphing part, I had to be a little bit more precise there because it can be tough to figure out if you just draw kind of half-assed, you'll make a parabola and then you'll make a line. Maybe you can still tell, but it's hard to tell if you draw it really small and imprecise which one is above. So especially since they both start at 0, 0. So all right, so that all you have to do, set up the integral, stop. Do not integrate it. I left very little space on the exam for this because I don't want anything else done, and I'll be really unhappy. But you're going to lose points if this was continued on. I would be upset because that's not what I want. I'm not testing that here. I'm testing that you can set up the integral, put it in a position to find the volume, but not find the volume. All right, so that's that one. Okay, finally, problem 6. Not sure if I'm going to do anything from 7 because I'm not 100% sure if I'm going to even put anything like that on the test. But so 6 is all use substitution. There's power rule, trig, E, ln. Right. So these beyond that they start to get repetitive and redundant. Like you do the same thing again and again. So I'm going to start with the E one. I'm going to do the power rule one that looks like the one on the test. So again, whenever you see E, that means that the U is the power of E. Then you're going to take the derivative of that, which is 3x squared dx. Be careful here. You're taking a derivative within a problem that you're doing an antiderivative of. So you have to be very careful. People screw this up. And they get the derivative wrong. They just put 3x here. It's not going to work if you do that. Now remember, your goal, whoops, like this is really bad. I forgot the dx there. So your goal is to take everything that has x in it and just put all u's in du there. So I have to get rid of everything that has x's. So I'm going to solve this for dx, right? Just divide this down underneath. This will work every single time. I'm going to slightly rewrite my integral. You don't have to do this. I do this just because it's more convenient. Okay, so now where the x third was, I put u. So I have e to the u. Now where this is, right? I'm going to replace dx. I circled the whole thing and I shouldn't have. I have to fix it because it looks stupid. Where the dx is, you have to put this. So I'm going to put my x squared is still there temporarily. I'm going to put du 3x squared. And then I'll switch to my horrible red marker here. Cross out the x squareds. Now again, oh man, it made the marker all black. You get 1/3 here, right? So you can put the 1/3 there, out in the front. You don't have to leave it there. So I have e to the u, x squared crossed out, du. I mean, it doesn't get any easier to find an antiderivative of. The integral of e to the u is e to the u plus c, and you got a third there. Would help if I can write a 1/3. And then just put back the u. So you get 1/3 e x cubed plus c. This works. Derivative of ex third is ex third times 3x squared, but the 3 and the 1/3 cross out and give you an x squared. So you could always kind of check with the chain rule to make sure that you did it correctly. These are not super difficult. Of all the techniques you're going to learn, trust me, this is by far the easiest one. They get much harder. All right, so I'm going to do a few more. Okay, so I had a choice on your sheet there between doing C and doing I. Though I don't think I like it enough that I would put one on a test like that. But what's nice about the fraction one is that it involves a little bit of factoring, has a little bit of everything. So as soon as you see the fraction, and if you notice, if I took the derivative of the bottom, it doesn't quite match up to the top, but it's got the right powers. Like it's got an x and then it's got a number without an x. So I know that it's kind of sort of close. So you're going to pick the u to be what's on the bottom. That means that the du is the derivative of the u. So it's going to be 2x plus 4 dx. Right? That's important because you're going to replace dx. So now again, I gotta start plugging in. So I'm going to replace x squared plus 4x minus 3 with u. I'm going to leave this there, but what I'm going to do is, I notice, look, you see 6 and 12. I know that I'm going to have to do this. So I'm going to factor out the 6, right? Divide the 6 away from there and divide the 6 away from there. And again, like you're in the 4th grade, make sure you did it right. 6 times x, 6 times 2, it matches. Now, I'm going to put this underneath there, right? So that means that dx is going to be du over 2x plus 4, right? So I have 2x plus 4 here, and then du over here. Now, 2, 4. Same thing. I could have did it over there. I'm going to factor out the greatest common factor of 2. Divide by 2, divide by 2, right? Just cut the numbers in half. Yay, look at this. Cha, cha. I'm going to give my red marker a break. Now, you have 6 divided by 2. This is not 1/3. This is 3, right? You put the 2 into the 6. So you get 3. And then you have du upstairs and u downstairs. There you go. This is your ln, dude. That's the derivative of ln u. So when you find the antiderivative, when you integrate this, you're just going to get ln u with the 3 plus c. And then put back what u is. So keep the 3 there. So you can have ln, the bottom, x squared plus 4x minus 3 plus c. Now we'll make sure. When I find the derivative of ln u, it's du over u. So that means that he should be on the bottom. His derivative, which is 2x plus 4, times 3 should be on the top. 2x times 3, 6x. That derivative is 4 times 3 is 12. That's on the top. So it matches. So again, antiderivatives opposite. But if you don't know the chain rule, derivatives, if you don't know the derivative of ln u is du over u, or the weirdness of my favorite, the 1 over u du, it's the same damn thing. I don't know why you wouldn't write that as opposed to this. This looks kind of silly to me anyway. All right, so you definitely have an e, definitely have an ln. Now we're gonna do a trig one. Okay, this is e. Now I'm gonna do multiple trig ones because this is when I discovered I had a mistake on my practice test that I had to fix. I'm gonna fix it now, and then I'm gonna upload the correct thing later when I put the answers there. So, but this one isn't wrong. But again, you need to recognize that, right? If you remember your derivatives, derivative tan secant squared, derivative of secant is secant tangent. So as soon as you see secant tangent there, you got to recognize that this answer is going to be secant. So you do the same thing. Whenever you see a trig guy, the u is always the angle of that trig guy. So it's going to be 8x. So that means the derivative of u is going to be 8 dx. That means that dx is going to be du divided by 8, right? This is the substitution that I'm looking for, that I'm looking to make. It's pretty simple. So wherever the 8 x's are, you're going to put u, secant u, tangent u. That's the easy part. And then you're going to replace dx with u over 8. There's nothing here to cancel out. There's no 4. I could have put a 4 here, and then you would do 4 into 8, but I didn't. I didn't put a number there at all. So you're just going to put du over 8. So that's 1/8. So if you like, just throw it out here. You don't need to leave it in there. You can do that, right? That's the 8 on the bottom, 1/8. Now, the antiderivative, the integral of secant u tangent u is secant u, right? The derivative of secant is secant tangent, and the u goes along for the ride. So you get plus c and 1/8. And now just put the angle back. So it's secant of 8x plus C. I mean, it's really that simple. I know it looks like it's too easy, but that's how you do it. It's not, this one is not that complicated. All right, now the next one I do, which I do have to repair, is slightly more complicated. Still not that more complicated. I do like this question. It was screwed up on the sheet. It will be repaired. On the sheet, it says tan. But, if I put tan here, that's not the derivative of tan. So the one I gave you can't be done. So I noticed it when I was trying to do my answers myself. So, the thing is, again, it looks complicated. Like, oh my God, it's so confusing. I don't know what to do. But I said to you, whenever you see trig, you pick the angle. Now, but there's multiple ones. The angle here is x. The angle of sine is cotan. So, if you start off trying to do this, where the hell is this going to go? I can't leave this here. I have to put a u here. And you have to recognize that this thing here is his derivative. Not exact, right? The derivative of cotan is negative cos squared. But you have to look at it and use a little bit of common sense and say, okay, I know it has to be one of the angles, but it has to be that one. And remember in class, I said the u is never complicated. It's not something crazy. You couldn't, you're not going to pick u to be cos squared. That derivative of that's not trivial, right? I mean, if you pick this to be your u, it's too complicated. It's too close. It's crazy. That derivative is really complicated. So it always has to be something simple. Now, the derivative of cotan is negative cos squared. Oh, there it is. Dx. So again, I'm going to put that down there. So that means that dx is du over negative cosecant squared. Now I'm going to start replacing everything. I'm going to put u where the cotangent is. I'm going to take my cos squared, and I'm going to move it to the end next to my dx. Now I'm going to replace the dx with this. Nice, careful, easy. Put du over negative cos squared x. These are going to cross out, but leave me with a negative. So you have to be very careful when you do this problem. So there's going to be a negative. Let me just put it in the front there. Actually, I won't do that. Let me not do that. Let me write it with the sign so it's more clear. So u, gone, negative is there, du is there. Right, so I'm looking for the antiderivative, the integral of negative sine u. Now, I know that the derivative of sine is not sine. So let me just go back real quick. I know that if I do the derivative of cosine u, it's negative sine u. Look at that. Very convenient, right? The derivative of cosine is negative sine. Son of a bitch, that's what I have. So when I do the antiderivative, that negative sign is gone now, right? I don't put negative cos u. That's not going to work, right? Because the derivative of this would have been positive. So it's only cos u plus c, right? Derivative of cosine u is negative sine u du. Worked perfect. The sign switch was already built in there for me, so I didn't have to do a damn thing. And then the u was cotangent. And like I said, I did accidentally write tangent there on the sheet. That was probably a copy and paste job that I forgot to just switch it, but it would be corrected. So like I said, the problem couldn't be done with tangent, but I know that I wanted cotangent there for this exact reason, because you end up with that negative sign that helps you out over here when you do the integral. So that's it. If you were to take that derivative, the derivative of cosine of something is negative sine of that times the derivative of that, right? So you have a negative. His derivative, though, is negative cos squared. So you have his negative and his negative, cross out, make a plus. Cotangent's derivative is there. Derivative of cosine is there. And the angle doesn't change, right? It's cosine u, sine u. So it does work. I mean, I'm not going to sit here doing chain rule derivatives to show you, but you can kind of in your mind make sure that it makes sense and that it works and that you did your signs correctly, because it's easy to mess it up. All right, now I'm going to go back and do power rule 1, because that's pretty much it for the trig. I mean, the trig will have more. I'm only going to ask one E, one ln, and probably only one power rule, but I'm going to show you which one right now. Okay, so this one is number 6F. Look, number 6A is a little too simple. It's not that it's a bad question, but I know that I'm going to give you one with roots because you need to know how to do it. And of course, I fucking wrote it down wrong, and I didn't even realize that. I love how I just put parentheses instead of a radical there. Yeah, same exact thing. Actually, that would have been pretty vicious to do that to you. Almost everyone would have got that wrong because if that had been parentheses there, you would have had to move it up to the -1 power, and that's just ridiculous. So anyway, this is what it's going to look like. It's going to now check real quick to see something. The derivative of this, the derivative of x squared is 2x. So I have the right power at least. I'm just off by 4. I already know that there's going to be a 4 because 2x. There should be a 2x here, but there's not. There's an 8x, and that's 4 times too big. So, but I still have to go through the whole process, so I will. So remember, square root means 1/2 power. So I have this, but it's on the bottom, so you can move it up. So this is where you get the power rule part. Like you don't recognize. It's like how is this a power rule one? Well, there it is. And as I said to you, whenever you have something being raised to a power, the u is the thing being raised to the power, right? You want your u to be something simple. Your u is not going to have a square root over that. That's too complicated, and it's not easy to take a derivative of. The u is always a real simple function. So take the derivative of x squared, get 2x dx. Now again, you're going to put the dx underneath. Divide. Put the 2x underneath the du. I said that wrong. Right, you're going to solve for dx, you get it alone. Now I'm going to do all my replacements. Again, I'm going to relocate him. I'm going to put the u there. I have u to the -1/2. Now I have 8x dx. Right? I like to do that just because it's more convenient. Now I'm going to put du over 2x over here. I'm going to cross these out. Gives me a 4, which I'm going to put in the front. Actually, you know what? I'm not going to put in the front. We don't need to do that. Let's make it 4. U to the -1/2. Gone, gone. 4 relocated. Du. So there we go. Now I'm going to do my move. And you're gonna see something really cool that I've had students in the past who try to do this in their head, and this is the exact reason why you don't do that. So you're gonna add 1 to the power. Again, let's do it like we're in the 3rd grade. Add 1 to the power. So you have u to the +1/2. Now I got to take that power, flip it over, put it in front. Plus c. Yes, I won't forget the plus c. So that gives me 8. I'm getting close to the bottom here. U to the 1/2 plus c. So that means that I get 8 times x squared minus 9 to the 1/2 plus c. Now, if you really want to, you could go write it like this. I'd recommend you not do that. I want this answer. I prefer this answer. I'll have that answer on my answer key. Now, at the beginning of this question, this is why it's really easy to screw this up because the power matters. I said that the derivative of x squared is 2x, so this is off by 4. But you see that wasn't right. It ends up being off by 8 because the first thing I would do is in that problem is multiply by the power of half and cut the 8 in half. So it's foolish to try to do them in your head because you'll mess up the power thing, especially if the power is a fraction. So it does look like that though, right? The derivative of x squared is 2x. And so there should be a 2x there, but instead I have an 8x. So you think, oh, I would just put a 4 in front. But it ended up being an 8 in front because you cut it in half first. So you have to be very careful with these. Don't try to guesstimate them in your mind. That's why I did that in the beginning because I've had students who will skip all this work and they'll just put a 4 there. But then it didn't work because the 4 doesn't work. It has to be an 8. So, you show me all the work of the way that I showed you. Every step that I wrote. Now listen, I'm writing it all out. I write it all out when I make my answer key. I do the same damn thing. So, that for all the substitution ones, we did an E1. we did an ln one, we did two trig ones, and then we did the power rule one. But like I said, after that, they start to repeat. They start to get repetitive. So there's no point just doing a gazillion of them because those are already all the variations that I could possibly ask you. Now, I think I will do. I'm gonna do one of number seven, just in case I put it there. All right. So if I were to pick a problem from seven, it's not going to be A. I already gave you an E1, and E works stupid because one of the numbers when you plug it in gives you e to the zero, which goes away, but then you end up your answer has like e to the fourth or e to the fifth or something. It's just stupid. You can't compute it. This one now it looks a little scary because you got some weird numbers here. I mean, you got pi over 12, which you never do this, and you got pi over 4, which we do. But the reason those numbers are there is because of that. So same thing. I'm going to try to do this one a little quicker. The u is 2x. That means the du is 2dx. So that means you're going to divide by 2. So I'm going to do this substitution very quickly. So you got 4 cos u. So where the dx is, I'm going to put du over 2. I'm going to wipe out that 2 into that and make that a 2. Now, I'm not putting the numbers here. We had this conversation in class. These angles are not going to be the same, and don't try to mess with them. Just put question marks or just leave it blank. Or you could just write the same thing. You really shouldn't write the same thing. So I have this. I'm going to do the integral of this. I know the derivative of sine is cosine. So when I do the antiderivative, I carry along the 2, and I put sine u. Where am I going to evaluate it? This would be the mistake. If you put pi over 4 and pi over 12 here, you're completely screwed. It's wrong. Because the u, look at what the angle was. The angle is 2x. You cannot just put pi over 4 here. It's not the same. It's not true. So I don't want you to do that. So what I want you to do is just put the 2x back. And then put the numbers there, which is pi over 4 and pi over 12. And then again, you'll understand in a minute why I did that. It gets confusing because the original constraints, the pi over 4 and pi over 12, involve x. Once you switch the variable to u, those are not valid anymore. So just ignore them. Look, I put question marks. Just do that. You don't, even if you put the numbers there, I don't care. But it's not precise. You can even just write A and B if you want. I mean, I don't know what they are. Can I compute them? Absolutely. I can put them right there. But I don't want to do that. I don't want to plug them here. I want to plug them here. So that's what I'm going to do. So I have 2 sine 2x. Now what's x? Pi over 4 goes first. Now you're going to see why I did that. Minus 2 sine 2x. Now what's x this time? Pi over 12. Right? Top one goes first, bottom one goes second. Now, pi over 4 times 2 is pi over 2. Right? You just divide the 4 by the 2. That 2 stays there. Minus 2 sine. Now same thing here. Put the 2 into the 12, you get 6. I mean, that's why the 2 is there, because you have to double the angles. So pi over 4, which is 45, turned into 90. Pi over 12, which is whatever, 15, turns into 30. So sine of 90 is 1. Sine of 30 degrees is a half. Nice. Right? Use your values as I gave them to you. So you have 2, take away. That's all 1. So all that work just to get to number 1. Right? So I did the u substitution a little quick there. But this is the part where there's trickery. Because once you switch the variable to u, I cannot write pi over 4, pi over 12 here anymore. So you just put A and B there then. Right? You don't, could you? Yes, I showed you could. I showed you in class that you can do both directions. You can actually you can solve. You could take the original x's and put them here, but don't do this. It's completely unnecessary. You have to put x back anyway. You're doing a u substitution. So the end of that u substitution is always to return x to its original position to match what you started with. So you may as well do that and then plug in the original numbers that I gave you. So if this is there, and again, I don't know it will be there, but it would be, I'd make one similar to that. So, but if I did that, then I wouldn't ask you a trig one like that on the u substitution problem, right? There'd be the e, there'd be the log, there would be a power rule one with a radical in it. And then there might be another trig one like 6g, but then I would put, so then instead of giving you, like 6e, or even, 6D. Instead of those, I would just give you this. Don't know if I want to do that. Don't know if I'm going to do that. But anyway, this is how you would do that one, just like in class. It's the same use of substitution. It's just that you got some extra steps to do at the end. And it gets tricky because you have switched to you. All right. So if it's there, this is what I want you to do. Just when you have made the substitution, just put A and B. Just leave them blank. You don't even have to write anything there. Don't put pile of 4 there. Because this will show me that you really don't get what you're doing. Like if you do this, you have just demonstrated to me that you don't know what the fuck you just did. That you just switched out of X into U, and yet you're still putting the X constraints there. That shows me a complete lack of understanding of what you're doing. So I'd rather you just leave them blank and don't write anything at all. Because then at least I know you understand that those original numbers do not apply to you. They only apply to X. All right. So I worked as much as I could. I hope it's helpful. I mean, I never have any videos for Calc 2, trying to build up the list. All right. So anyway, I wish you guys good luck on the test. Just be really prepared and, work the questions, check the answers when I post them all. The review sheet already has the answers. The practice one I'm going to post later on. So, all right.